All right, we are making our way through this chapter. It's a long chapter. We've spent a lot of time on proofs, and that's the purpose of the chapter.
Yep.
We've spent several days on some of these sections here lately, and so on. You should be getting to where you understand proofs, and and you're getting used to some of the pieces that are showing up, and so on. And so this throws a little different thing to our proofs here.
Yeah.
We're actually going to end up with our proofs in a different way. So we're actually trying to prove parts of triangles congruent now.
Right.
Instead of trying to prove triangles congruent, we're trying to prove just a piece, corresponding piece, congruent. So if you think back to the section 2 where we defined what two congruent triangles meant, the definition of that was all 6 pieces were congruent, all 3 sides, all 3 angles. And so we're kind of going back to that here. If 2 triangles are congruent, then their corresponding angles and their corresponding sides are congruent. Again, if you think about one triangle landing on top of another triangle, if those 2 are congruent to each other, we're kind of going backwards. If the 2 triangles are congruent, then each one of those corresponding pieces are congruent. And we're trying to get to those pieces.
Kind of think of it as you got an old like Jeep, right? And you break apart on your old Jeep, and so you go to a junkyard and you're trying to find a Jeep that has a part, or you're trying to find a Jeep that's the exact same year as your Jeep and it has the exact same parts in it, because you know that if it's this year Jeep and all the parts are still the original parts, that you could take the piece off of that Jeep and put it onto your Jeep and it should be the same thing. Yeah. So the whole Jeep is similar to your whole Jeep, but you just need a part from it that should fit directly onto yours. So that's kind of the whole thing, is get to know what they are, and then you can say different things about it.
Yeah. Good analogy, yeah.
Yep.
So we use this acronym, Cpctc, and you're just going to get used to us saying that all the time. Cpctc stands for corresponding parts of congruent triangles are congruent. All right? So let's go back to that. I don't know why that's not spelled out here, but basically it's the title of the slide.
Yep.
Corresponding parts of congruent triangles are congruent. And so the Cpctc is what we're going to put in the reason in a proof.
Right.
And it's going to end up being our last reason.
Yeah, it's typically always at the end.
In a proof. Now, not the fact that we just proved that, not the fact that we proved triangles congruent. And so in the proofs that we've been doing, it's been SAS or SSS or whatever. We're going to go one step beyond that now. And so we'll look at some examples of that. And so here's just a quick question based on that. Which triangles in this diagram are congruent? And so we have right triangles.
Yep.
So we're thinking HL possibly. We do have the 2 hypotenuses congruent. We've used reflexive so many times, guys, you should just automatically see that anymore. And so they share Km. So Km is congruent to itself by reflexive, and so that is a leg of both triangles. And so these 2 triangles are congruent by HL. So triangle JMK is congruent to triangle LMK by the HL theorem. All right? And now we're going to, go ahead.
And so the idea here, guys, is now that we know that both of those triangles are actually congruent, we could say maybe 2 angles or 2 sides that we didn't necessarily know were congruent originally. Now we could say they're congruent by Cpctc. So if I was to say, okay, well, now that I know that triangle JKM is congruent to triangle LMK, I could say, all right, well, if those 2 triangles are congruent, well, then by Cpctc, angle L must be congruent to angle J. And even though we never proved that originally, now that we know those triangles are congruent, all the corresponding parts have to be congruent.
Yeah.
Whether you're an angle or your side.
Yeah. You know what, guys, I got to admit here, I didn't even see the JM congruent to LM. I don't really know why that was there on the slide. But that would be a piece that we could come up with afterwards.
Yeah.
Because we could prove the triangles without that from before. I don't know why that's even there. But now we could say that that's true. JM, the bottom, is congruent to the bottom of the other one, LM, because of Cpctc.
There you go.
Their corresponding parts of those 2 triangles being congruent. Okay. So we're going to go through a couple proofs here and show how this is used.
So hopefully you've been really working out the proofs, so that way as we go through some of this, it's not new. It's just focusing on step 5 at the end there, and that'll be where you'll see it come in. So first of all, we want to lay out our givens. So
you guys have done this. No, it'll come in.
Okay, so
you guys have done a proof like this so many times already.
So at the very end, we want to prove that side AB is congruent to side CD, which is a shift because usually we would have said, all right, hey, prove the triangle is congruent and then stop.
Yeah.
So now in order to get to where AB is congruent to CD, there's no way to get there, guys, unless you prove that the triangles are congruent. You just will not have enough information, or you won't have a means to show that AB is congruent to CD unless you first prove that those two triangles are congruent, and then after that we can go back and do this. So let's just get to it, and it'll start to make some sense. So I can say that AB is congruent to angle A is congruent to angle B. Sorry, angle B is congruent to angle C. Okay, and that segment AB is congruent to segment CD because of given.
Right.
Okay, and so from here now, I just want to start, looking at some things that I know to try to figure this out. Well, we can also say then that the angle BAD, all right, angle BAD, so that angle in the upper left corner is congruent to angle CDA. Okay, based on the fact that I have parallel lines being cut by that diagonal transversal, I can say that those two angles are congruent by alternate interior angles. Battery's getting low here.
Yeah.
Okay, so I can say that AD, or angle BAD is congruent to angle CDA by
Grab some power.
alternate interior angles. Okay, so that's that rule there. Now you could have, well, let's just go to the next step here. So from here, okay, I see that those two triangles are sharing side AD. Okay, and so I could say that AD is congruent to AD by reflexive. All right. Now you guys could have switched statement number 2 with statement number 3. It doesn't really matter. You could have said reflexive first and then gone alternate interior after that. It doesn't really matter as long as it's in there. Okay. But now, do I have enough information to prove that those two triangles are congruent? So just look at my information. Angle B is congruent to angle C. There's one angle. Angle BAD is congruent to angle CDA. There's two angles. And then I have side AD is congruent to side AD. So now I have angle, side to prove that triangle ABD is congruent to triangle DCA via angle, side. So now that we've got the two triangles congruent, okay, now that we've got those two triangles congruent, now I can go on to my last statement, which is to prove that AB is congruent to CD, which there would have been no way to do this without that. So now I can look at, say, okay, so AB is congruent to CD because now that I know both triangles are congruent, all the parts that are corresponding have to be congruent as well. So therefore, by Cpctc, I can say that AB is congruent to CD.
So that last step is really the only new thing here. You guys have done that proof up there before.
Yeah.
The only new thing is proving a specific piece out of those triangles congruent, and they'll just pick one.
Yeah.
You could pick several.
Yeah.
They'll just pick one, and the reason is going to be Cpctc.
Yeah. I mean, you could even say that AC is congruent to BD by Cpctc. That's another piece we don't know.
Yep.
You could say angle BDA is congruent to angle CAD by Cpctc because that's the final piece that we don't know. Okay, so it's really all it is it's that law of detachment. What can I conclude? Now that I know this, I can say this.
Yep.
And that's all it is, deductive reasoning.
Right. Okay. Let's just do another example. So we have these two triangles, and you can already see, just by the diagram, you've done enough of these proofs, you can already see what we're going to have here. But angle N is given to be congruent to angle P. NM, the top there, is congruent to PQ, the bottom of the other one. And we're being asked to prove that LQ, one of the sides, is congruent to LM, one of the sides of the other triangle. Okay? And so we'll put in our given, angle N congruent to angle P, NM congruent to PQ, that's given. You know what we're doing next. We're going to those vertical angles, so angle NLM is congruent to angle PLQ. Those vertical angles are congruent, and that's the reason. Vertical angles are congruent. Okay? And so do we have enough to prove the triangle's congruent? Yeah, we've got two angles and a side. We just have to figure out the order. And so if we look at that order, we're going to be able to show that the two triangles are congruent, and these do just fold over on top of each other. And so it's triangle NML is congruent to triangle PQL, and the reason would be angle, side. We have two angles and then the side that's not included, it's another side. Okay, Well, now we know the two triangles are congruent. We could prove any of the other pieces are congruent.
Yep.
We're just going to use LQ and LM being congruent, and the reason would be is because they're corresponding parts of those two congruent triangles. So Cpctc.
Yep.
All right. So really, it's what we've been doing all chapter. It's just one extra step, and all it is a piece of the two triangles.
Yep.
So, okay, guys. Not a whole lot new here, but you need to catch this. It's very important. Okay, so we'll do some more practice in class once again.